Um, why is there no picture? No, it is on. It's green. Isn't it? Did I put the wrong cable in? Perhaps. I must have the wrong cable in. Let's see. Is there any other? Oh, for goodness sake. Okay, it's one in three possibilities here. Right. Not this one. Next.
Shouldn't it at least show something like it's searching or
Yeah, it's a piece of junk. Did it turn itself off?
No. The power is green, but like anything else is on.
Maybe you should use the whiteboard.
That's so old school.
We don't do that in 2018 anymore.
Which is that connected to? I can't tell. This seems like the main cable to the projector. But should this be like at least on?
It's glowing like that.
This is what you said should be happening, huh? Okay. What? Yeah, there we go.
What is this?
I'll adjust. There we go. Okay. So, a couple of things to look at. We'll have a look at a workbook question. We'll have a look at some calculus. We can do other topics too. You said there was an 8-2. What topic was that? Yeah, what? A probability one. Okay, so let's just start with that workbook question Mo has been waiting 2 weeks to do. So, what is it, Mo?
Page 82.
Yeah.
Question B.
82. What number?
Question B. 4B.
All right. Read it to me.
For each of the following, solve for t.
Okay.
It's the limit of 2t and 1.
The limit.
No, it's like the integration. Sorry.
Oh yeah. Okay. Oh, this one.
Yeah.
From
1 to 2t.
Yeah.
3x plus 4dx is equal to 5.
Are you sure I didn't do this in class?
No, you didn't.
We did it in extra math.
Ah. Should I make him watch the extra maths videos? No, he's been waiting 2 weeks. Okay. So what we do here for this one, we integrate.
Oh, it's gone.
Ah, Angela, you knocked it out.
It's back. It's back.
No, hang on. I don't want you to. Let me just. Well, steady. No, stop touching.
Touching it.
It's very sensitive equipment. Oh. Steady. Okay, don't touch anything. Right, so you integrate as normal. So here you get
3 over 2x.
3x squared over 2 plus 4x, and the limits are 1 to 2t, and that should equal 5.
How to find t?
Find t, yeah. So we put 2t in first, so we get 3 over 2, 4t squared, plus 8t, and then we put in 1, minus 3 over 2 plus 4, and that should equal 5.
Wait, how did you get 4t?
2t squared.
Oh, okay.
So 2 goes into 4 twice, so that's 6t squared plus 8t. That's 11 over 2, is it?
Yeah.
So minus 11 over 2 should equal 5. I shall bring the 5 to the right. So minus 11 over 2 minus 5 is minus 21 over 2. equals 0. I'll multiply by 2. There's no simplifying I can do here, is there? Can I factorize? Does it have factors? It might not have factors, Young Tang.
Think quadratic.
Yeah.
What?
Minus 4 plus root 79 over 6.
There are the two answers. Does that not match the back, or?
It's minus
Well, it's over
2.15
6.
and 0.8.
Oh, the I put it as
Yeah.
decimal. Yeah, okay. Yeah, it's all over 6.
All over 6, yeah.
Okay. All over 6.
That took 2 weeks.
Ooh, burn! I wouldn't stand for that, Mo.
At least I work, I do anything, something.
Oh, it's on like Donkey Kong. Right. Okay, fine.
Oh, can we do the second one?
The second one?
Yeah, that one is an area under the curve.
Oh, an area under the curve. Oh, okay, fine. What page now?
84, 22.
Page 84, question 22. Actually, I just double. Right. Here's an area question which can be quite difficult. Can you give us the info? So, what's it say?
The line y is equal to minus x minus 4
Minus x minus 4.
cuts the cubic.
Yep.
Y is equal to x cubed minus 5x squared minus 2x plus 1 at 3 places. The result of the intersection is to
Yeah.
reduce 2 bound regions.
So what? Yeah. Okay. So you have a cubic like this. That's this guy. That's the C, the cubic, and then you have a line which is sloping down. So one would imagine like this. My question is, what is this area, and what is this area? Now, before I can even begin to answer that, I have to figure out here, here, and here what these points are. Okay. So let's find out where these meet. We'll make the equations equal to each other because they're both equal to y. So I have minus x minus 4 equals x cubed minus 5x squared minus 2x plus 1. So that means I have x cubed minus 4x squared. No, sorry. Yeah. Minus 5x squared minus x plus 5 equals 0. So clearly when I look at this, it's not hard to guess 1. Because what I can see from just looking at it is if x is 1, then this and this will cancel. And then this and this will cancel. So I made it quite obvious that you should try 1, which means you can, well, I thought it was obvious anyways. You can put in x minus 1 as a factor into the cubic here. So that will be x squared. That will be x cubed minus x squared, yeah? So that's minus 4x squared minus x plus 5. So what have I got here? Minus 4 x minus 4x squared plus 4x. So that's minus 5x plus 5. So that's minus 1. Yeah, and that solves it then. What are the solutions to this? Let's see. Oh, this is going to have surds, isn't it? No, this is going to have factors. You can't have two numbers multiplying to 1 and making 4. Right?
I didn't put it. I didn't do long division. I just put it in the.
Yeah. So what are the two roots here of this quadratic? They're going.
I didn't do the long division. So I just got overall. I just put my overall equation into the.
Yes.
the 3 zeros
I just
there.
want to know what are the
Plus
roots
1,
here.
minus 1 and plus 5.
No, something sounds either you're wrong or I'm wrong. Made a mistake, Amjad? Yes.
2 plus.
Wait. Yes.
How's negative 5x? 5x.
Huh? Where?
Negative 5x.
Here.
No, down.
Here.
Down.
Here.
Yeah.
Yeah. I didn't write the last line down because I didn't bother. If I multiply by minus 1, I get minus 5x plus 1. Oh!
You get a remainder.
Yeah, I get a remainder.
Just means that it's not a.
So I've done something wrong, okay. Well, 1 is a root, isn't it?
It is.
Right, so let's double check.
It's minus 6x, the second
Yeah.
class.
Back in time, rewind.
Oh.
Yes, where is it?
It's 2x, it's 5x. The cube
Yeah,
x,
Yeah.
Oh, the cubic.
yeah, 2x. It's 2x.
2x.
Yeah.
2x?
No.
But the x here has to come over.
No. The
No,
last
and
step
we
should
are
be negative
dividing.
5.
This is...
Yeah.
Why is this minus 5?
No,
Why
it's
is it minus 5?
The last step.
Hang on, not two voices. Firstly, go.
Okay. When you finish the equation just now, you put x squared minus 4x minus 1. But then it should be minus 5.
It's just the last line that was wrong. Okay, so let's just double check. So the minus 4x you think is right here. So that's minus 4x squared
Minus 4x.
plus 4x, and then I subtract and I get minus 5. It's just literally the last thing I did. Yeah, okay. So plus 5. I should have written
Negative 5.
minus 5.
Yeah.
Alright, fine. No, so it's just the last line. Okay, so that's my punishment for skipping the last multiplication thinking I'm finished. That's what I get, and it serves me right. Okay, so the solutions here would be, let me see, 5 and minus 1.
Yes.
Minus 1.
Yes.
So if I look at this graph, this is minus 1, this is 1, and this is 5. So if I want to calculate the area, I'd have to integrate from minus 1 to 1.
Yes.
Now, what do I integrate? I integrate the cubic minus the linear.
Yeah.
And I actually have already done that. That's x cubed minus 5x squared minus x plus 5 dx. You realise, if I say cubic minus linear, that's exactly what this line was, because I took this over and minused it. Now, then I have to do plus. Now, this area here
1 to 5.
is 1 to 5, and it's the line minus the cubic,
Yes.
because the upper is different in that shape. It's not cubic minus linear, it's linear minus cubic. Because it's a different, it's bounded differently.
So swap the signs.
So, yeah, that's it. It's only the signs have flipped around, isn't it? So it's minus x cubed plus 5x squared plus x minus 5 dx. Now, I'm going to stop there because the rest now is straightforward. You integrate, you put in the limits, you integrate, put in the limits, and subtract. I think the difficult part is getting to this step. But once you have the integration, then it's fine after that.
Yeah.
How far did you get? Like, what was the...
The second part, I didn't know that you had to linear mind.
Yeah. Yeah. But you see, if you deleted this in your mind and pretended the question was only that,
Yeah.
would you have said linear minus cubic?
Yeah.
You would have, you see, because it's because you just previously did it the other way around. Yeah. Okay. That is satisfying?
Yeah. Thank you.
Graham? Yes.
I still find it sometimes confusing to know which one goes first.
The upper. The upper. Just whichever one is on the top. That's all.
Actually, 21 and 22 are the same. Question 21 and 22.
Exactly the same or same idea?
I just say they have the same idea and the same process.
But are they the same numbers?
The answers are the same.
Do you know what I probably did, Young Peng? I probably took question 21 and changed it slightly to make it look different. Is that what I did?
Yeah. Because it looks like the second part.
If you just move to the one side and you will get the same equation as 21.
Wait, 21 and 22?
Yeah.
Ah, yeah, that's what I did. You're exactly right. I manipulated 21 into making a new question. Well spotted. Yes? Yes, now we can look at some past papers. So which, you have an A2 to look at, and let me just write down which ones we want to have a look at. So version 2, A2?
17, 18,
Hang on, wait. Oh, there we go.
17, 18.
That's the recent one.
Yeah.
Version 1A2. Okay, that's a probability. What did you want to have a look at?
Version 3, 16, 17.
Yeah.
Question B2B.
B2B. And what type is that?
It's GP.
GP. Okay.
And also version 2, 16, 17.
Yeah.
B6.
We did it in class.
No, we didn't.
Well,
We did?
They weren't with us.
I don't think we did B6. The integration.
There are a few
There's-
questions that we could have solved.
We did B5. Yeah. That's a calculus one. The integration, is it? Integration. Okay. That's These are fine. So let's do these three, and then we can see what to do after that. So version 1 now. A2. Okay. I'll come back to this list in a second. So, X, Y, Z are three independent events.
You're not right.
Oh, I know. My hand's... Oh my goodness, I thought my hand was moving. No, I know I'm not writing. It's okay, thank you. X, Y, Z are three independent events. Event X occurs with probability 0.39, Y with 0.53, and Z with 0.08. Find the probability that none of X, Y, Z occur. So first you can get X or no X, and then after that you can get Y and no Y, and then Y and no Y, and then finally Z, no Z, you know.
Oh,
them
is this
there.
what they mean? I thought, okay.
No, it's good to do this because the language can be the problem here.
I actually thought they were, like the, you know.
Well, there's
Three
many,
things that happen.
there's many ways to do it. What is the probability of X not happening? No. It says it here. 0.661,
6-1.
is it?
Yeah.
This is version 1, sir? Version 1?
Yeah. What's the probability of Y not happening? 0.47. And Z not happening? 0.92, if I look at the question. So, it's just that times that times that gives us the answer here of no X, no Y, and no Z. That's all.
So when they say independent events, that means like one after the other.
No, they shouldn't really have used that word yet, because that comes up more in the second probability chapter. But for the moment, we can think of it as X, Y, Z. They're all lined up one after the other, and the outcomes don't affect. So in other words, what they were trying to say is, on this branch, it's the same numbers as this branch. That regardless of what happens in X, it's the same result for Y afterwards. Yeah.
The probabilities of X, Y, and Z happening, it adds up to 1. That's why I was confused.
Oh, that's very interesting that they deliberately pick
Yeah, I
numbers
was
so the three of
wondering
them
if
add
they
up to 1.
wanted me to put 0.00.
Yeah, I see what you mean. That's very interesting. I wonder if they did that on purpose. I really don't think they should have used the term independent events, because as far as I can remember, that's actually a term that's in the probability chapter number 2. So whether they should be using that, I don't think they should. I'll have to double check the syllabus here in a moment. Anyways, that's that one. The next one is version 3 B2B.
16, 17.
Oh, is that the year before?
Yeah.
Not the recent one. Okay, so can you read the question then to me, since I don't have it in front of me? Yeah. Maybe I can open it here. You think you have it handy there? Okay, what is it? So,
Wait.
oh yeah.
Sorry.
Ratio. Oh no, I touched something.
I didn't touch anything.
16, 17 version. I'm winning. Version, which one?
Okay, I got it.
Version 3?
Yeah.
Which B2B?
B2B.
Right, I'll just open it right here. Ah. Okay. So what they say here is you have a geometric series. Those fools, they said geometric series, but it's geometric sequence. 1 1/3, 4, 12, ... This is a sequence, isn't it? Because a series means what? Yeah, sum. Yeah. So, no speak English well. Okay. What is the A here? 1 1/3, and the or? 3. Which term is the first term to exceed 50 million? So you want to know when will UN be bigger than 50 million? So the formula you remember is A or n minus 1 is bigger than 5 times 10 to the 7. The A is 4 over 3. The or is 3. Bigger than 5 times 10 to the 7. I'm going to just bring that fraction to the right. So it's 3/4 of 5 10 to the 7. Now, I also am going to change that instead into 3n over 3 rather than having the minus 1. And I'm going to bring that 3 up to the other side. So I have 9/4 5 10 to the 7. Now, what should I do next? Yeah. So I'll have log 3n is bigger than 9/4 5 10 to the 7. Take the n down and divide by log 3. Log 3 is positive, so there's no need to flip the sign. So n needs to be bigger than 9/4 times 5 times 10 to the 7 over log 3. Let us calculate that. Fraction 9 over 4 times 5 times 10 to the power of 7 over log 3. Oh, that's much bigger than I thought. How many is that? 1, 2, 3, 4, 5, 6. Oh, sorry. Yeah.
Yeah.
What did I forget to put in?
Log.
Yeah, I forgot to write log here because I was taking log of both sides. So it's log of that. So can I easily fix that on the calculator? So what's the answer here? N must be bigger than or equal to 17. So from 17 onwards.
Can you scroll up all the way to the series? Okay.
You mean to the sequence?
Yeah, to the sequence.
Yes,
yeah.
of course. Yes.
Whatever they.
That's 1 1/3 at the beginning. Sorry, got cut out. Yeah. Is it just the first part that you needed done? This part was the problem part. Did you figure out what you did wrong?
Sir, regarding the schedule thing, can
Yeah.
we not do a schedule and still do it all? Anyways.
Sorry. Could you at least email me that that's your plan?
I'll just do it all on the same day. So.
No, you won't. You'll do 4 exams in one day. Will you?
I don't know. Maybe 2 days.
Yeah, that seems a bit more realistic. Okay. You're still writing that down. Did you figure out your mistake? You didn't. It's a mystery. At what point did what I do differ to what you did?
We're starting, instead of just taking the fraction, I multiply 1 over 4 over 3 times 3. So
Oh, you can't do that.
Why?
Because there's a power on the tray. This can't go into the bracket. If there's a power on the tray.
Sir, why did you make the sign equal to again for 17?
Yeah, because here n is bigger than, what was it I got on the calculator? 16.87, so,
It has to be.
yeah.
Can you explain how you went from when you took 4 over 3 to the other side?
Ah, yeah, I just brought the 3 up and the 4 down.
Yeah, and then the step after that.
Ah,
The
I
left
split
side.
this guy into 3n over 3 by using the second rule of powers.
Oh.
Rule 2. There's an integration to do next, isn't there?
Yes. B6B and C.
Version 2 B6, okay.
B6C.
Yeah, but I might end up doing the whole thing. Let's see what it's like. Yeah, I'll just do the whole thing.
Just 2017, 18.
The recent one, yeah.
No, this is 16, 17.
Oh, 16, 17.
Yeah.
Is it much different to this one that I gave?
I haven't looked at that.
What's the 16, 17? What version? 2.
Yeah, 2.
Let's have a look at it. So, okay, I'll do that one. I'm doing. This is what year? 16, 17?
Yes.
16, 17, version 2, B6. Okay, let's have a look at this. So, what you have in this question, you have a concave quadratic like that, and you have this line that cuts through it like that,
And that's on
and you have this point here, and I guess later they're going to ask you for this area.
Yes.
You know this point here, that's A, and they give you A, they say A is 424. You don't know this point, they call that B, and they say that's just AB. And they give you the quadratic, it's y equals 10x minus x squared, which by the way is the same thing as x 10 minus x. So that's handy because it makes me clearly see what the limits here are, 0 and 10. And the first thing they want, they also tell you that that line is a normal here. So this is a normal, this line at this point here, A. It's a normal. And the first part is to find the equation of that line. So what will I need to do first? I'll need to differentiate to get my m. Well, not quite. dy dx equals 10 minus 2x. And what's the x here? Come in. What the heck happened to you? You're 39 minutes late. Okay. Okay. 10 minus 2x. And what's the x here? X is 4. So that's 2.
Yes.
So what's the m for the normal? Minus 1 over 2, because it's perpendicular. So you have y equals minus 1 over 2x plus c. What point can I sub in? 424. So I get 24 equals minus 2 plus c. So c equals 26. Yeah? Alright, so y equals minus a half x plus 26. 4 marks. The next thing they want to do is for you to calculate a and b. calculate a and b. So they want you to find where the line and the quadratic meet. So we just have to make the two equations equal. The quadratic is, where's it gone? 10x minus x squared. That equals y, which equals minus a half x plus 26. So I'll get x squared minus 21 over 2x plus 26 equals 0. I took everything to the right. Multiply by 2.
I think it's 21 over 2.
Is that not minus a half x minus 10?
Okay.
Oh, sorry, thank you, Young Peng. I forgot to multiply the 26 by 2. So what should I have here? 52. 26 times 2, yeah? Okay.
For the first one it's 26.
Yeah.
But then it's
Then the second one is
yeah.
52.
Last line.
Because you didn't multiply it by 2 yet.
Okay, fine. 26 there. Yeah, okay. Right. So here I'll have, no, don't take 2x minus 13, right?
Yes.
X minus 4 equals 0. So that means x equals 13 over 2 or 4.
But we already knew that. That's the one.
Yeah, we don't want the, we want the, which answer?
21 over
We want the bigger answer. We don't want the A, we want the B. So we want the bigger answer. Which one is bigger? This one is bigger. So the A is 13 over 2, and the B, because remember it's just like this, x, y. How can I get the B? I can sub this back into, say, here.
Can you explain why you chose 13 over 2?
Ah, you can use the quadratic formula.
No, I mean, why you
Oh, why did I choose that and not the 4?
yeah.
Yeah, because these two answers represent where the line meets the quadratic, and that happens twice. And the question wanted you to find the point B, which is to the right of A, so I have to choose the bigger x. Okay, what's the B? If I sub my A, 13 over 2,
91
so
over 4.
is 19 over 4?
91 over 4.
91 over 4, okay. Yeah.
Is that always the case? You always choose the bigger.
No, just in this picture, because they asked for B. So the x value for the B will be bigger than the x value for the A because it's to its right. Okay.
How did you get B?
I sub the A, which is representing x, into this guy.
And they say it's 6.5. Is that's 13?
That's 13 over 2. Yeah. Last part, C, is to find the area. That's really, really nice for 7 marks. Like really, really nice. Because it's just one, no, it's 2 integrations. So what are my integrations here? So if you look back at my picture, you have to split this shape into 2. So here I'm integrating under which curve? The quadratic. Yeah, from 0. And then here,
Oh.
the linear. So my integration is 0 to 4, 10x minus x squared dx, plus 4 to 6.5, minus a half x plus 26 dx. That's the answer once you calculate it.
Okay.
So we might as well calculate it. This will be 5x squared minus x cubed over 3. Put in the limits of 0, 4, plus minus a quarter x squared plus 26x, 6.5 and 4. Is it okay? Question? You sure? So if I put in the 4, I'll get 4 squared is 6, that's 80. 64 over 3, and then 0 and 0, plus whatever 6.5 squared is over minus 4 plus whatever 26 times 6.5 is minus, and then I have to put in 4. So 4 squared is 16, 16 over 4 is 4, minus 4, 52, 104. So that is 100. What's that? 240. Help the teacher out here. 240 over 3, 24, 176 over 3. Minus 169 over 64.
How is it 169?
Is 6.5 squared over 4 not 169 over 64? I thought everybody knew that. No?
6.5.
You see?
Oh, okay.
26 times 6.5. I'm running out of power here. Yeah, I've only got a gig here.
169.
This is 169?
Yeah. No, it's it is.
Yeah, that's 169.
It's over 16.
Yeah.
Over 16.
No, first one.
169 over
over
16,
yeah.
not 64.
Yeah.
Are you sure?
Yeah.
Okay. Oh, sorry. 6.5 squared over 4.
Yeah, it's 116 or 69.
I am correct here.
No.
Mm.
16.
169 over 16.
Yeah.
Okay. Yes, it is. Okay. That's a minus 69. Yeah, I know. That's what I'm waiting for someone to do because I don't have it open.
No, it's 169 over 64.
It's only 4, it's not 16.
It's
Because the
okay.
4 is not squared.
Yeah, but 6.5.
Squared. It's squared.
Okay.
No, it is. You're thinking what I thought originally, yeah. Look, someone just give me the final answer, please.
117.1.
117.1.
5621.
Final answer. Thank you. Get rid of this nonsense. Okay.
Can we do a similar one on the question 3?
In the recent exam?
No, the one.
The previous year? Okay. This is a lot for... This is very little work for 7 marks. You know? Because 1, you have to form the integration. 2, you have to integrate. 3, you have to put in the limits, which you can do easily on your calculator. And 4, you have to add them up, which again you can easily do on the calculator.
That got a bit confusing because they added that extra x equals a line. It does not make any difference.
No, it doesn't. It doesn't. It really doesn't. Who was asking? You were asking me for which version?
3, 1, 16, 17.
B6. That's a bit more interesting.
Yeah,
You don't like it? Okay. Let's have a look. What's really nice about this is that you can type this in on the calculator to see if you got the right answer here, which is really nice. Can I scroll down? Yeah? Yeah? Okay. So we're looking at version, what version? 3? B6 of the same year.
Yes.
So in this picture here, what you have is this situation. A convex quadratic with this line that goes through it like that, and it looks like they're forming a triangle here with the piece cut out. So like they're looking at this area here. Yeah. What did they tell us? They tell us the quadratic. What else did they tell us? They tell us this point here.
5, 3.
What else did they tell us?
And the line is normal at the point.
Which
That's
one? The 5, 3 again?
Yeah.
It's another normal at this point, is it?
Yeah.
Find that equation. Fine. So dy dx equals 2x minus 8. but x is 5, so that's 2 again, isn't it? So m is minus 1 over 2. Y equals minus 1 over 2x plus c. Sub the point in as normal. 3 equals minus 5 over 2 plus c. Is that 11 over 2 for c?
Yes.
So you get y equals minus a half x plus 11 over 2. 4 marks. Next, they want you to find this point here. So, Sevi, you were asking me earlier, do you take the smaller or the bigger one? So in this case here, you'll be taking the smaller x because you're looking at finding the one to the left. Let's solve. We have x squared minus 8x plus 18 equals minus a half x plus 11 over 2. I'll take everything to the left. X squared minus 15 over 2. X, is it? 18 minus 11 over 2. 36, 25 over 2. Equals 0. Multiply by 2. 2x squared minus 15x plus 25 equals 0. So obviously it's going to be a 2x, an x, 5 and 5, I think. I want minus and minus. So x is 5 over 2 or 5. Well, which one is it? It's this one, isn't it? If I sub that in, what do I get for y? Do I need y? No, actually, they just want the x. Part C, they wanted to know where does this this line cross the x-axis. Well, how do you find that? How do you find where a line crosses the x-axis? Make y 0. But it's obvious it has to cross it at 11 because only the value of 11 here could make this add to 0. You know, I mean, you can solve it if you like, but it's obvious that x has to be 11 because the only solution that makes this 0 is minus 11 over 2 plus 11 over 2.
You have to show the word bigger than
Well, it's 1 mark. So I think they would take... for 1 mark, no. No.
They said B.
Can you show the graph?
They said for B,
All
you know, I must show all your workings. Yeah.
Can you show the graph?
This one here. So this point here is 11, and this point here, what was it? What did we get for x in part previously?
5 by 2.
So 2.5?
Yes.
Yeah, okay.
Trying to think why you chose the smaller one this time.
It's to the left.
Yeah.
So, yeah,
Smaller than the 5, which is this one.
Oh.
think of it as x-axis.
I can think of 3 ways to calculate the area. I don't know which you would prefer. So, all of them have integration. So,
easiest.
so what you could do, one method, you could you close the back door there, please? Thank you,
Would
Yunfeng.
it be area under the curve for this, and then area
Well-
plus area under the line?
Is that broken? Oh, good. Good. Okay. Oh, Jacob. That's broken, is it? It is. Maybe. You can open it. You can close it. Just slam it. There you go. Enough effort. Okay. Right. What was I saying? Oh, yeah. So there's 3 ways to do this. The first way is you can get the area of the red triangle by using a half the base by the height. Disadvantage, you have to first work out the height. Not a big deal. You just put the value of x in. Second way is you, put the 2.5 in to either the
Oh, to
quadratic
get
or
y,
the
to
line
get
to
y,
get the
okay.
y here, to get the height. That's the first approach. Second approach is you could integrate under the line
Yeah.
minus integrate under. No, sorry. The second approach. Misspeaking. The second approach is.
Way more
Area
work.
under the
Hang on. Pause. Pause. Shh. I didn't finish my first approach. The first method is to get the height, get the triangle, and then minus the area between the line and the quadratic. So the first, if I was to picture it like this, it's first you get the triangle, then minus the area between the two. That's the first one. The second one is I can think about it as the area under the quadratic
Yeah.
and then plus the little triangle. So that would be
That seems easier.
what?
They're both the same.
Plus the triangle.
No, that one you have to do 2 integrations.
Yeah, because how would
You
you
have to
find the
find-
area between
You have to.
the line and the curve?
Yeah, well,
You don't even need to find.
but
y
this
here.
one here, it could be an integration, or I think the last one is probably the area under the curve plus the
area.
triangle, but just using a half the base by the height.
Yeah.
Because what I like about this triangle is you actually know the height. What's the height?
Yeah.
3. And what's the base?
6.
6.
6. So a half 3 times 6 is 9, isn't it?
Yes.
So this area you already know is
9.
9. So it's just this area here. So the answer would be 9 plus integrate from 2.5 to 5 x squared minus 8x plus 18 dx. Now that's even easier than the last one we did because there's only one integration and it's still 7 marks. So, yep.
Could you have integrated the line between 2.5 and 11? And
Hang on, let me just pick it up. Between 2.5 and 11, yeah.
Yeah, and then subtract that from the area under the line between the area under the line between the quadratic, like you did in the first, but instead of using trigonometry to find the area of the triangle, you use.
Oh, yeah. That's, yeah, we could. Yeah. Okay, continue.
But if you find the area under the line and then you find the area under the curve.
No, his math is the same as my first one. He's just wanting to use integration to get the area of the triangle under
so
the line.
so
Yeah,
between
there.
2.5 and 11.
Yeah, that's fine. That's fine, yeah.
This one is you know the equation that we found in B?
Yeah.
What is that?
The equation we found in B.
Yeah, so 2x minus 15x plus 25.
2, huh?
2x minus 15x plus 25. That's
Oh, yeah.
the area,
No, solving that equation was finding where the line and the curve meet.
but it's subtracted to find the, I don't know how to word it.
Subtracted.
Because you took the,
5 over 2.
you took
Yeah.
the curve and
Yeah.
then you subtracted the line here.
Well, rather, I made the curve and the line equal because I want to find where they meet. I equated the two equations. It's a simultaneous problem.
I mean, it's like the previous graph that the previous B6 question we did when you explained.
No, you need to be... What I did was I had y equals a linear, y equals a quadratic,
Yeah.
and I made them equal. So I was solving for where they meet, which had the same effect as saying linear equals quadratic, so quadratic minus linear equals 0. Yeah, but it had no... But I'm not getting the area between the line and the quadratic.
How about the question before when you told us?
The question before was interesting because I did this to get the points where they meet, and when I wanted to get the area between the line and the curve, I realised it's the quadratic minus the linear, which coincidentally I worked out already for solving something else, unrelated. It was, in other words, I took advantage of a calculation that was the same but for something unrelated.
Is it because the one previously coincidentally is the equation for the?
They bounded in between the two, yeah.
Okay.
Yeah. Yeah.
You wouldn't. I'm going back to the question I asked you.
Yeah.
I wouldn't have to split it between 2.5 and 5 and 5 to 11. I could just do.
Yeah, the single one. Yeah. Okay. So as I was saying, for 7 marks, this is the beginning of a 7-mark question, and you realised, like, is it which version? I just wanted to show you something here. Right. Just to put this into context for you, when you look at this question for 7 marks, you realise that's actually a lot for 7 marks, because if you got that in section A, and I'm looking at version 4.17.18, a question like that in section A is only worth 4 marks. So effectively you're getting 3 extra marks for being able to form that integration from the graph. So if I was to look at the marking scheme, I think getting to this step should be 3 marks, and then the rest should be the remaining 4. So let's integrate this. That's 9 plus x cubed over 3 minus 4x squared plus 18x, 5 and 2.5. So if someone can just type this in on the calculator, 9 plus 125 over 3 minus 100 plus 90 minus 2.5 cubed over 3 minus 4 times 2.5 squared, and then 18 times 2.5 at the end. And then that is it. So that's 7 marks once you get the equals here.
That's 15.
Which one?
9
Total?
9 plus 15 minus 105 over 4.
So you give me the final answer?
Yeah, I'm just giving you what they said.
Oh no, you can just give me the final answer.
And then the
15.45.
15.45, and really they do like 3 significant figures, so 15.5.
You know, keep the exact number.
You can, yeah. You can. Is it an exact?
Use a fraction.
Is it exactly 0.45?
No, 458.
But does it continue?
Yeah.
Like, is it a long decimal?
Yeah.
Alright, fine. But does it have an answer as a fraction?
Yeah, 58.
Yeah?
11 24.
58 and 11/24.
15.
Oh, sorry, 15 and 11/24. That makes more sense, yeah. Yeah, young Pang. You can leave it in a fraction form.
Okay.
Yes. I think this is, you see, a lot of students don't like doing the integration question in the exam, but this question here, it's fine actually. It's easier than the one we did before. Than this one. Right. What's next now?
Do you want to try B5?
What's B5? What?
It's the same paper. It's optimization.
Okay. Same paper, scroll back to B5. Yeah. Question before this one. Oh, sorry, do you...
Yeah, just 1 second.
Yeah. That is perfectly natural. Okay. H, X, and 2x. And you're told that the total length of all the edges, so this plus this plus this plus this plus if you add up all the edges, it should be 162.
What version is it?
It's version 3. So if you add up all the edges, you should get 162 centimeters. Find h in terms of x. Okay, so how many edges are there of length h? 4. Of length x?
4.
And of length 2x?
4.
Yeah. And this should equal 162. So if I divide by 4, why am I doing this? 2x equal, yeah. If I just add my x's together like I should have, I get that. And what am I looking for? H. So I get h equals 162 minus 12x over 4. I can divide everything by 2 at least, right? So that's 81 minus 6x over 2. Right, that's the answer for part A. Yes?
Do you get marks if you stop at
If you just went here, that'd be fine. B. What's the volume? So the volume is x by 2x by h. Yeah? Which is 2x squared by h. Question?
Yes.
What?
Why wouldn't it be h over 2?
I've divided here. Well, I divided by the 4.
Yeah.
And I divided everything in this by 2. I don't need to do it on the other side.
Why?
Oh, because if I have a fraction, I can divide the top and bottom by 2 and nothing else changes. I cancelled everything here down by 2. Divide by 2.
Just simplified it.
It's already divided.
You're not happy with that? Okay. You'll get it, trust me. It'll occur to you later. Okay, so the volume is 2x squared by h. Oh, that's nice because they cancel. So the volume is 81x squared minus 6x cubed. Perfect. It's another 3 marks. C. Maximum volume. dv dx is 162x minus 18 x squared equals. Yeah, you got it. I told you you get it. Right. Does 18 go into 162?
Yes.
How many times?
9.
So if I take 18x out, this would be 9 minus x.
Yes.
Obviously 0 is not an answer, so the x is 9. 5 marks for part C. 5 marks for those 3 lines. Good. D. Confirm it's a maximum for 3 marks. What's the second derivative here?
It's
162 minus 36x, and x is 9. That is definitely negative, which makes it a max.
why do you not second derivative in C?
That's,
That's what I did.
what am I doing? Good question. This is my first derivative, and I just differentiate again.
The maximum, isn't it the second one?
Oh, you're sleepy too, I see. Yeah. The maximum is the first derivative is 0.
Okay.
I don't know, this is something I find odd, but students, they always get confused and think, oh, you have to make the second derivative equal to 0. No, it's always the first derivative, max or min.
So what's the second for?
To decide if it is a max or min. A positive second derivative means it's a min, and a negative second derivative means you have a max.
So you do the second part, the second derivative, just check.
Just to check if what your answer was a max or min.
So
That's negative 126.
I trust that it worked out to be negative.
So the first one is to find the max.
No, the first one's to find the max, but technically speaking, you don't know if it's a max or a min. It could be one of them. The second derivative tells you it's a max or a min, for sure. Now, you could, listen, guys, look.
You could tell from the cube.
Yeah, you can tell. Look here. Listen. No, you can explain in a moment. Just 1 second. Listen. In part C, when we wanted the max, we got two solutions, technically. What are the two solutions?
0
9 and 0. Now, one of these is maximum and one of these is minimum. Obviously, the 0 has to be the minimum answer because 0 would represent no volume. So how could that be the maximum answer? In part D, you had to confirm that what you gave as a maximum was indeed maximum. And the second derivative confirms it's maximum because it's negative. Yeah.
But you already know it's a maximum because you have minus 18x squared. So because you always told us that the minus...
No, but the original needs to be minus 18x squared, not the derivative. Yeah. Yeah.
But still, the cube is negative as well. So.
It'd be very weird if... I mean, it couldn't possibly be 9 as a second minimum.
Yeah.
But the verb was confirm.
Yeah.
Like, provide confirmation. Yeah. Yeah. I mean, this is a max, and we confirmed it with the second derivative. But is there any other method we might use to confirm that this answer represents a maximum? Sketch it, yeah.
Find
Graph.
Below 9 and above 2.
Yeah, you could look at x equals 8 and x equals 10, and the volumes for those values should be smaller. Yeah.
It's the simple substitution.
By
Yeah.
volume, you mean volume or value?
Volume. Is that okay?
Yeah.
Are you sure?
I was just confused.
Yeah. We can continue. The last part is to find the maximum volume. So you just sub in x is 2. So 81 times 4 minus 6 times 8. So what is that then? That's 48, isn't it? And that's 103.24.
Why
Is
are you
it?
putting 2?
Oh, sorry. Why did I put 2? I really don't know. I should be putting in 9.
Squared.
Squared and
Cube.
cubed. What is this? This is 81 times 81 minus 6 times 81 times...
527067.
Thank you. The total?
527067.
527067
How do you make it
cm cubed.
How do you make it 3 significant?
Yeah, 3 significant figures would be 527000 cm cubed. Again, this is all reasonable, I think. There wasn't anything outrageously difficult here. I mean, it's just a cubic you have to differentiate, really.
I just don't know when to apply the formula.
You have my flowchart? Yes. All right.
Breathe.
Yeah. What's next now? What's next?
What?
Yeah.
It's wrong.
The 527.
Yeah.
What should it be?
2187.
And so you're saying Angela can't use her calculator. That's what you're saying. What's the answer?
2187.
2187 cm cubed. Is he right?
Whoa.
Yeah, this makes sense.
I'm always right.
He is right.
He is right.
And
To
the
187.
three significant figures are significant
Ah.
figures.
2190.
Ah. Yeah, you mistyped here.
What did I do?
You said 81 cubed,
This is
but if you were going to go with 81, it should have been squared. It was 81 by 81. Yep.
Don't pay
You see now, Amjad thinks he's going to be. Amjad thinks he's great now.
Genius.
Yeah. Okay.
2190.
Hmm?
It would be 2190.
Yeah, if you were doing 3 significant figures, yeah. I mean, they'll take this as the right answer too.
yeah, this is
Some questions they really specify you will get 1 mark for rounding correctly.
Yeah.
So here, because the answers, here's the answer is exact, you can leave it as 2187.
If you get a decimal, they'll ask for significant figures.
Or they might expect you to round it.
Oh.
Yeah. Right, what's next now?
Can we do a problem with it?
Yeah, just pick one out that you want to do.
I didn't choose one.
Hmm?
I think we do this.
You have all the papers there. I mean, you can have a look at them. Yeah,
Can you let me know when you unlock version 1?
I've already forgotten about it. You'll have to email me to remind me to unlock it.
I'll email it to you.
Can we do
Yeah?
13, 14?
13, 14? All right. Yeah, okay. 13, 14, let's have a look.
Version 2.
Hold on, man. 13, 14, let's see. 13, 14? Is there even a 13, 14? Oh yeah, here it is. Okay, which version, Amjad?
2.
Which question?
6. B6.
B6. Also another integration, is it? So tired of integrating. Okay.
Can we do the this one?
Oh, make up your mind. Which one do you want, Amjad? Amjad!
B5.
B5. B5.
Yeah, B5.
Okay.
How come they give cylinders always to some exams and then squares in other exams? It's much easier with squares.
Yeah, it's not consistent difficulty.
What the?
And about
What the?
mine asked the
What
question.
is this?
Yeah, I'm telling you, I'm gonna ask the question.
No, this is the question I believe we solved in B5.
No, is it? This is
Okay. We are going to look at which part, Amjad? The whole thing or just one of the halves? The B one. You don't like the look of it. Okay. B5B. Can you open that, please? 1314 version 2 B5B. Got that? Can I start this one?
Yep.
Fine.
Guys, do you have that one open? Because I'm not going to draw it because I'm too tired to draw it. It's two triangles, isn't it? Two triangles. You have it open? Yes? Mariam, you have it? Huh? Okay. Guys over there, you have it open there? Okay, let's have a look. Figure 1 shows a quadrilateral ABCD where AD is parallel to BC, AC is 34, BC is 48, and AD is 32 centimeters. Angle ACB is X, CAD is X, and ACD is Y. And the question number 1. The area of triangle ABC is 384. Find X, or sine X rather. Okay, so I will use the formula area is equal to a half, 48, 34, sine X. When you rearrange this for X, or for sine X, you'll get 8 over 17. When you cross multiply and divide, your fraction simplifies to 8 over 17. Okay, so far? Part 2. What's the cos x? So if we want the cos x here, the best thing to do is to draw a triangle representing the sine x. So sine is opposite over hypotenuse Does Pythagoras say this is 15?
Yeah.
So what's cos x?
So
15 over 17. Part 3. What is the angle, or what's the side CD? What would be the best way to get CD? Sine rule, I think. Sine rule. So you can say CD, CD over sine x equals, what other side do we know?
EA.
Hang on, let me think about this. We have CD.
Sine x or sine x or?
No, I know we have the sine x. I'm just thinking.
No, we have cosine x. So
No,
we
hang
can-
on, but we have sine x as well. We could use the cosine rule.
Yeah.
Yeah, well, hang on. That's what I'm thinking, which would be easier. I'm looking at the picture.
CD squared or 34 squared.
Oh, we have the two sides and the angle in between. Yeah, okay, I get it now. So, yeah, cosine rule.
Yeah.
CD squared equals 32 squared plus 34 squared minus twice 32, 34 cos x. Ah, so just in one line, you type that in and you have your answer for 3 marks. So I'll just let someone type that fraction and root in, please. $16.124. Yep. Okay. Last part is to find the angle of y. Now,
125.
is there any sneaky way to do it?
1, 2, 4, 5.
125. 16.125.
1, 2, 4, 5.
1, 2, 4, 5.
Well, it doesn't matter because I do 3 significant figures at 16.1. Do I have to use the sine rule to get y?
Yes.
It's the only way, isn't it? So I can say sine y over 32 equals sine x over 16.1. And you actually know what the sine x is. What did we say it was earlier? What was sine x earlier?
8 over 17.
8 over 17. So that means y will be sine inverse 32 times 8 over 17 over 16.1. Bring up the 32 and sine inverse.
It is 76.97958.
76.97. So that would be 77.
Yeah, they're the same, so. And then that's one.
I got 69.
I got
No,
69.3.
69.2.
Maybe I'm
Well, so 69 point.
28.
Can I please see?
Yeah.
Maybe you're alright.
Oh,
Yeah.
they have a graph in part A.
A graph.
Trig graph.
Just do it step by step.
Is that a graph?
Don't need to.
Oh, maybe we should do part A because that's a
You
trig.
shouldn't give me a wrong answer.
Ah, yeah. We'll do part A. We'll do part A as well. That was part B.
Oh, I have a question.
About what?
Well, it's in 17, 18.
Okay, but I want to do part A first and then I'll do it. Can I scroll down? Scrolling down. Part A of this question was, in your answer book, sketch the graph of 2 sine a half x between minus 360 and 360. Right. Start, end, min, max. So normally sine starts at 0, ends at 360, goes from minus 1 to 1. What's the effect of the 2? What's the effect of the 2 here? Maximums and minimums change. And what's the effect of the half? Yeah. So it's not 0 and 360. What will it be now?
0 and 180.
Ah, everyone got it wrong. 720. Now, let's draw this. So,
Oh, it stretches it.
yeah, no, it compresses it.
What?
So like if it was 2x, it compresses by a half. So if it's a half x, you compress by 0.5, which is double it.
It would be 720 if it was 2, not half. If it was half, then it was 180.
No, a half x makes it 720. 2x would make it 180.
Minus 2.
Huh? Well, I'm continuing. So, how big do I need to go on the y-axis?
2.
To 2. So there's 1, there's 2. And on the x, we're told to go from minus 360 to 360. However, my box here goes up to 720, although they don't really need me to add that much in. Right, so minus 2 is down here. So remember how we do this? We make our box. There's 2. There's minus 2. There's 0. There's 720. We split this up into quarters. Like that. And then because it's sine, where do I start in this box?
0.
You start here. And I go up, down. And I actually stop here because they don't need me to do this part. But I'll just put it dotted like this.
If you sketch the
The extra,
extra will they give the marks.
it should be okay, but you can never, it should be okay, but I want to check the marking scheme. And then what do? We copy this and paste it to the left. So if I copy and paste that, it's going to be, I have to try and really picture it, it'll be going out to, it's like over here, isn't it?
Yeah.
And it goes up,
Up.
down, yeah, so I can kind of see it now.
Can't you
It
just
would be,
think of it as, continuing?
no, don't make me think, please. Okay, so that's what you get. So actually, this looks like an upside down cos that they made you draw.
Yeah.
Yeah.
It looks like a minus cos x starting here. Yeah. Okie dokie.
So it's the derivative.
Kind of.
Yeah.
2. Y equals cos x. It's been reflected in the x and translated through one positive y unit. What's the new equation? Okay, so firstly, how do you reflect it in the x? What change do you make the equation to have it flipped around?
Negative.
Well, hang on, reflected in the x? Oh. Yeah, so where do I put the minus, Amjad?
Before cosine.
I think it's before the x. Now we have to be careful with the English here. It didn't say reflect through the x. It said reflected in the x. So they're not meaning that you flip it around the x. They mean that the x is flipped around. The difference between through the x and in the x. It's a grammar thing, I believe. And then lastly, how do I translate it 1 unit in the positive y?
Plus 1.
So plus 1, yeah. So the answer will be 1 plus cos of minus x. Now
Can you please repeat?
which part?
Please.
Sir?
Part
Yeah, maybe they want the value of cos x to be negative. That's what they mean.
This English is not clear. But it does say the graph has been reflected in the x. Oh, flip, what does in the x mean? Maybe I'm wrong here. Maybe it does mean the minus in front of the cos.
Yeah, because they want the value to be a negative.
Hang on, let me just Google.
Can you just check the markings?
Yes, you're correct there. It apparently reflected in the x means the same thing as reflected through the x. So that's minus cos x plus 1. Right? Yeah. Okay.
Yes.
Right, what one did you have now?
Version 4, 17, 18, question B5.
This is going to be a good one. Oh.
It is.
Oh. Alright.
I don't like these. Pick one. Don't pick both.
1718 version 4 B5.
5.
Have a look at that. Let me just build up the motivation here. Figure 2 shows a water trough which is uniform with length y, has a cross section made of a semicircle radius x. The trough has no top, it's open.
Oh.
Well, it wouldn't be a very good trough if the pigs can't eat from it, so there's no top onto it. Find an expression for y in terms of x, and you're told the volume.
Yeah.
You're told the volume. So, the volume is a half pi r squared h.
Because it's half of it.
It's half of it.
Yeah.
So you have 64000 pi equals a half pi x squared y. So then y equals, cancel, 128,000 over x squared. Oh, for goodness sake. Right. B, what's the surface area? So the area here is pi.
By surface area, what do they mean, sir? Like the top? Like they want to know the opening? The surface area or inside?
Oh, thank you. Yeah.
Inside.
No, the surface area.
Minus.
I think it's the whole thing.
You can.
Because
That's
it's
a very
different.
good question.
It's different.
Yeah. Oh man, they're being very bad here. Do you include the inside and the outside?
That's
The
what I
internal
think.
and the external?
I think
Yeah.
that's the right thing.
Yeah. Do you know, I know what they want, and their English is bad here, because, the surface area, do you have the area, both the inside area and the outside area, because they're both part of the surface?
Yeah.
Or do they just mean the internal?
Yeah.
But they said show that the outside surface
I
area.
think they want the outside.
Oh, good. They say outside surface area.
Oh, is it?
Now,
Yeah.
I kind of, Mo, just to be clear, I kind of knew it was going to be the outside anyways, because usually what happens here is you're concerned about the amount of metal you have to use.
Yeah.
So you wouldn't want to count the same sheet of metal twice.
Yeah.
So it's just going to be either the outside or the inside, but never both. So the outside area. So if you look here at the picture, you have a circle on the outside, because you have a half a circle and a half a circle, so you have a full circle. Plus, you have a rectangle, and the rectangle is y by pi or
X.
no h, yeah, isn't it?
It's gonna be sides.
Yeah, that's the area of the curved part. Yeah, isn't it?
R is X.
And or is X.
And
Oh, sorry, I wrote, yeah,
Yeah.
X here and X here. So that is, yeah.
I'm sorry.
Yeah.
Why are you?
they said it's given by
Okay, okay.
the
Well, yeah, so if we don't get this, we're screwed. Pi x squared plus 128,000 pi over x.
You did it.
Yeah, it worked.
Oh, that was a Y.
Yeah. Very hard, very hard.
just pick one shape. Why give us both?
Guys, can we continue? Please, no talking. C. dA dx equals 2 pi x minus 128,000 pi over x squared, and that should equal 0. Bring down the power, reduce the power by 1. So x minus 1 becomes minus x minus 2.
So is it plus? Not minus.
That's minus because it was x minus 1.
Oh, okay.
Yeah?
Oh, okay.
What can I cancel here? Divide everything by
Pi X.
pi. So you have 2x equals 128,000 over x squared. So what should I do next?
Take x to the
Bring the, so that becomes cubed, and then
Divide by 2.
divide by 2, so that becomes 64,000, and then cube root 4t.
Yeah, 40.
Confirm it's a minimum.
That's 50 point.
No, it's 40.
It's 50.39.
Is it? Cube root of 64,000 is not 40?
No, it is.
It is.
Yes.
I.
Oh yeah.
D! Second derivative. So second derivative here is 2 pi plus 256,000 over x cubed. Bring down the power, reduce the power by 1. This is obviously positive, which makes it a minimum.
260 pi? No. It's not yet.
Yeah.
Steven, why did you make it plus?
You brought down the minus 2. Yes, no?
Oh, makes sense.
And finally, you sub this answer in here to get the last part. E. Area is pi times 1600 plus 128,000 pi over 40. Cancel, cancel. That's 3200 pi plus 16. So 4800 pi is the answer here.
1507.
Sorry, Steven?
Yeah.
Is that supposed to be over x raised to the power 3 or over x raised to the power 1?
Cubed. Minus 2 minus 1. Minus 2 minus 1.
Minus 3.
Yeah.
That's wrong.
Hmm? Can you just switch the light on there for a second? Let's take the attendance here. Can I just borrow your pen for a second? It burns! Wait guys, I'll just take the attendance here before you go. Can I close this?